Okay, all right. So in the last class, we have started with the exception handling and we were discussing like the unchecked exception. We have seen some examples and the last example that we have seen like how can we define the multiple cash flows. Okay. So this was our last example that we discussed yesterday. Copy this. Or, so this was the last example that we discussed yesterday. The next topic that we are having here is something called as what? Unreachable code error. Okay, Harshita. Then we have the problem of waste. Then- Okay, we'll discuss that later. Okay, at the time of attendance. Now let's focus over the topic. All right. So here the next topic that we are having is what? Unreachable code. Okay. So while like we are going to define the multiple catch clause, always remember that the exception child class must come before its parent class. Actually, what they want to say here, like we can see here, because we know the exception is the parent of all the classes, or we can say like the arithmetic exception and the number format exception. Both are the child of what? Both are the child of the exception class. Alright, so like if we are defining the multiple catch clauses, so while defining those multiple catch clauses, you should remember like when we define parent, okay, the parent should came after all the childs. Like if we'll put parent first before the child, then let's see what will happen. Let's suppose I have put this cash flow at the starting. So now what will happen? As we can see here, like let's suppose the user enter the value of this as hello, value of a as in hello. So it cannot be converted into integer. So in that case, what will happen? It will throw a number format exception. So what will happen? Here the runtime system will like check the catch statement, and here you can see it will be catched here. Why? Because you can see the exception is the parent of the number format, and as we know the rule, like we can receive the child object into parent, so obviously it can be handled. And in the same way, let's suppose the value of b is 0. In that case, it will throw what? It will throw the arithmetic exception. Again, the compiler will came here and will check for exception, and obviously it can be cached here because again the exception is parent of what? The arithmetic exception also. So in that case, no matter what the exception is, all the exception will be cached here by this cache clause. So that means what? The next two cache clauses will never run. Okay. So this is what? This is an unreachable code. Okay, so you can see here the runtime system, the compiler will never reach to these cache statement that I have defined here. All right, so this is called here what? Unreachable code error, and this is the compile time error. Means if you like to try to compile your program will not compile. You will be having such type of error. We want to see it, just save it. Let me save it. Let's show with the name call. Open here. See. And you can see here, you are getting an error exception number format exception has already been called. Okay. And exception arithmetic exception has already been called. And where these two exception has already been called? By this one, by exception here. Because we know it is the parent of all. Okay. So I can't put parent before the child. Like in that case, I can't put it like in between of these two also. Because now, okay, it will be in like unreachable code error for arithmetic exception. So the parent should always come after the child. All right. So this is the rule we are having here. And when you see the number format exception, the arithmetic exception, which one the child or which one the parent, remember these are like came at the same level. So there is nothing like uh, a child parent relationship exists between the number format exception and arithmetic. So you can put them in any order, the number format and arithmetic. But the thing that you should remember is what the exception class should be at the last because this is the parent of all the classes. Let me know if anyone having a doubt in this. Is there any doubt? Anyone?
No, sir.
All right. The next topic that we are having here is what the different places to handle the exception. All right. So we can handle the exception in the method where it occur, or like if let's suppose I do not want to handle it there, I can also handle it while calling the method. Like I can be like in some other class, inside some other class, and from there, like let's suppose I am calling a particular method that may generate the exception. So it is also possible to handle it from there also. Okay, so we'll see that. So in the first example, we'll try to handle the exception in the same class where it can occur. Okay, let's say it. All right. So what we have here, we have a demo class that is having a method name input, where like we are taking the value of AB from user and then we are dividing it. So obviously that it can generate the error. So we put it within the try block and we are handling it within the same. You can see here within the input method, I'm also handling it. Okay. According like as we have handled it in the last example. So this is exactly the same. Okay, then we have the disk method that just going to print the values. And now we have the main class that is called here, where I have just created the object of D1, okay, and I'm calling the input and disk method. So this is a plain example here, where like we are handling the exception where it can be generated. The second way is what, like let's suppose I have not handled the exception in the input method. So in that case, what can I do is while calling like when I will be saying the D1 dot input, there I can handle the exception. Okay, so I can put the D1 dot input within the try block. Okay, so what can we do is just remove the try from here. Okay, and what can we do in that case? Because we know like the input is the method that can generate the exception. So we can put that within the try like this. Okay, now what can we have? We can have the catch statements that I already defined there. Let me copy paste it from there. Okay, so this is how it is going to be done in that case. Are you getting it? Like you can see here, what I have done is I have put the D1 dot input within the try block and I am handling it accordingly, like in the last example. So now you can see we are not handling the exception where it can be generated. We are handling it at the time of calling. Okay, so this is the second way to handle. Handling exception in another class. That is the one that I have already shown you. Okay, one thing that you need to be changed here is what you can see there. Uh, okay, but these are the default we can access. Okay, it will. All right. So is there any doubt? So here you can see like we can handle the exception in the same class where it occur or inside some other class from where like we are calling the method of the class that may generate the exception. So there are the two places where we can handle it. Anyone any doubt in this? Then let me know.
No doubt, sir.
Okay. The next we are having the topic is what throwing our own exception. For like I told you, like we can make use of the keyword throw uh, to throw the user defined exceptions. And here, like what can we throw it? Remember that it should be the object of the throwable class. As we know, like throwable is the parent of all. Okay, so it should be a category of class that belongs to the throwable. So we can only throw what? We can say in other word, we can only throw as the throwable objects. Okay, all right. So let's see the example here. All right, so what we are having here, we have a class named demo that is having the input method. Okay, and here like we are asking the value of a from user. All right. So here, like I need a condition if like user will be entering the value of a less than 0, then it should generate an exception. So obviously, the compiler automatically can't generate exception for this particular situation because like this is in a user defined situation here. Okay. So here like we can throw our own exceptions. Okay. So here like we can say what if a is less than 0, throw what? So here what we are doing is we are creating the object of the runtime exception that belong to the unchecked exception. As we know, like the object that belong to the runtime or any of its child will come into what? Will come into the unchecked exception. So it will throw an unchecked exception named what? Runtime exception. This is the parent we can say of all the unchecked exceptions. Okay. And here we can also pass a message like whatever you want to pass. Like here we have passed what? A is wrong. So here like we are creating the object of the runtime exception, throwing it. So remember it. You can only throw what the throwable object means. As we know, like the throwable is the parent of all, and the runtime exception is in a predefined exception. So we are creating the object of that, and we have just found it. And same is the case with B. Okay. All right. We have a set well defined there that is setting the value of ABC to XYZ. Okay. So D1 dot input has been put within the try block that you can see here. Okay. The input method can like generate the exception here. Okay. So what type of exception can be generated in the input method? The first one is the number format exception. The second one is the runtime exception that you can see. And third one is what? Here if the C equals to A upon B, it can be the arithmetic exception. Okay, so it is in a, it's not completed. There will be more code. All right, so we need to handle them accordingly. So you can see D1 dot input has been put within the try block. Okay, then I'm going to catch the exception accordingly. First of all, we have catch the arithmetic exception, then the number format exception. As we know, the number format and the arithmetic will came at the same level. So you can put the number format first or the arithmetic exception second. That will not matter. Okay, so you can put them in any order. All right. And when we have the runtime exception, runtime is the parent of all the unchecked exceptions. So here the runtime will be the parent of number format as well as the arithmetic exception. So it is important like the runtime exception will always come after these two statements, after these two catch statements. And finally, as we know, the exception is the parent of all the exceptions, no matter is a runtime or something else. Okay. So after the runtime, we can put the exception. Okay. So this will be the this will be the hierarchy of the catch clauses here. Okay, and it can only be put in this particular order. Only the order of the first two can be changed, but the runtime and the exception, okay, the catch clauses has to be put like this now. Okay, so anyone any doubt, then let me know. In this program where we have make use of throw keyword, and also like we are taking care of like we should not have any unreachable code error. Anyone any doubt in this?
No, sir.
So next category of exception that we are having here is what the checked exception. And there will be like making use of the last keyword that is what throws. So the checked exception, as I already told you, is a category of exception that like you have a compulsion to handle them. Okay, if like you are defining a code that may generate a checked exception, then it will be a compulsion to handle it. Otherwise, like your code will not even compile. Like in the last example, you can see here. You can see here like the code that you have written here, what type of exception it can throw? It can throw the arithmetic exception, it can throw the runtime exception, it can throw what? The number format exception. And these three comes into the category of what? Unchecked exception. So like it is not a compulsion to handle them. So here like you can see I have handled it. But if you want, okay, you can also write it like this, like d1 dot input. Let me remove everything here. Okay. And then I can say what d1 dot disk and it will run perfectly. But the problem will arise when there actually will be certain type of exception. In that circumstances, what will happen? Your program will terminate with the message that this particular exception has occurred. So this is what will be happen if you will not handle the unchecked exception. But the important thing is what here? Like you will not be forced. You are like it is not a compulsion here to handle them. Okay. But let's suppose this is the code. Let's suppose the code is generating some type of what checked exception. Like let's suppose here I'm writing what IO exception. And as we know, the IO exception is an exception that comes into the category of what checked exception. Okay, if this will be the case, and now if I will try to compile the code, it will give you error. Why? Because you have written some statement there. Okay. So here like the input method may generate the IO exception. Why we are saying may generate? Because it will only be generated when the value of a is less than 0. Okay. So here the input method may generate the IO exception. So it will become compulsion to handle it. So either you need to handle it here, okay, or at the time of calling. But you have to handle it. Otherwise, like if you will now try to compile your code, it will not compile. Okay, so this is the difference between checked and unchecked. Okay, so now let's see the topic. Okay, here is an some of the most common checked exceptions. The first one is the IO exception that is related to the input output. That is caused by what? Input output stream related exception. Next, we have the SQL exception that caused while executing the queries on the database that we'll see later. The class not found exception caused when the required class is not found. Okay, these are some of the checked exceptions we are having. And like here, what actually these will be? These will be all the classes that belong to the exception class and all of its child except the runtime class, because we know like the runtime and all of its child will be the unchecked exception, and all the remaining one that belong to exception or its child, okay, will came into checked exception. Okay, so let's see in program here. Hmm. And will you also be seeing the throws keyword here? So you can see I have a class named demo. And one more thing is what I have imported the IO exception that belong to what IO package. All right. So we have the roll number and marks. Set roll is the method. Like if the R is less than 0, now we are throwing what the IO exception. So as we know, like IO is in a checked exception, so it is compulsory to handle it. So how can we handle it? Either we can put this code within the try catch block, or what else we can do is we can make use of the throws keyword just to indicate that like this set roll method may throw this IO exception. So this is the use of the throws keyword here that can only be used like to indicate like that a particular method can throw this type of exception. Okay, like here it can throw what IO exception. And that way, like here you can indicate the multiple exception. These are going to be the comma separate list of exception here. Okay. In the same way, we have the set marks, but here you can see like it is generating the runtime exception, and that is what? That is an unchecked exception. So like it is not a compulsion like to make use the throws keyword here. Uh, at the time of calling also, you need to handle it. Otherwise, your program will not compile. So like we have used the d1 dot set roll, and as it will call the set roll, as you can see, it can throw what IO exception. Because it can throw the exception, now it becomes compulsory for the caller of the method to handle it. And that is why like we have put it within the try catch. Okay, so we take the IO exception, runtime, and the exception class. Okay, the hierarchy of this will remain the same. Okay, and this is how we are going to handle. So let me know if any one of you is having any doubt in this. So we have seen like the checked exception here. The only thing that you need to be keep in mind is what like these are required to be handled. Okay, at the time of like declaring it as well as at the time of calling it. At both the places they are required to be handled. Yeah, anyone any doubt? This is the last topic that we are having here in the exception handling.
No, sir. No, sir. No doubt.
Okay, so now we are done with what? With the exception. Okay, let me start with the multi-threading as well. Okay, so here the next topic is, and we can say the last topic of the core Java is what? Multi-threading. Okay, so what? Okay, I hope like all of you must be aware about the multitasking. Can anyone tell me what is multitasking? Anyone? What is the meaning of multitasking? Your phone, your operating system, everything is multitasking these days. What does that means?
So multitasking means, uh, yes, sir. Running two or more programs simultaneously.
Hmm. Or we can say the
Yes, sir.
task. Like you can see here your operating system, whatever you're using. Okay, you can perform multiple tasks at the same time. Like for
So
example,
running two or more programs simultaneously.
you are listening the music at the same time, you are playing the game at the same time, you are writing something. Okay, so in that way, like you can perform the multiple tasks at the same time. And this process is called what? Multitasking. In the same way, what can we do is here in case of Java, we can have a single program, okay, which are going to have multiple parts. And all those multiple parts of the same program can be run concurrently or simultaneously. Okay, so in that way, in that scenario, each part of the program is called a thread, and this process of running the multiple thread at the same time is called what? Multi-threading. So if we say the multitasking, it means what like we are having the multiple programs, multiple separate programs, or we can say multiple separate tasks. But in case of multi-threading, what will you have? We'll be having a single task or single program that is going to have the multiple parts, and each part of that program can be run simultaneously with each other. All right. So in that case, each part of the program is called thread, and the process of like we are will be able to run those thread at the same time. Okay, simultaneously is called what? Multi-threading. All right. So are you getting what exactly the multi-threading is? So in case of multi-threading, like we are considering only a one program. Okay, that can have like the different part that can run concurrently. But in case of multitasking, like there can be the several multiple separate programs that can run concurrently. All right.
Right, sir.
So I hope now you are getting the different point, like what exactly the difference between multitasking and multi-threading. So like there is a difference between multitasking and multi-threading. Multitasking means what? More than one process, or we can say the programs are executing concurrently. For example, like one process of program playing any song and other program or process allowing you to surf the net on the browser. Whereas multi-threading means what? One program contains two or more parts executing at the same time. Like for example, a text editor program allowing you to print and type at the same time. Okay. One more thing here is what before actually moving towards. So you can see here, like if I'm considering the multitasking, as we know, like we have just a single processor. So is it possible for a single processor to execute multiple tasks at the same time? Is it possible?
Yes, sir. Yes, sir.
No, it is not possible. Look, actually, what will happen? Your processor can execute only one task at a time. All right, it can't execute multiple tasks at the same time. So here we can say like there is nothing at this like the concept of multitasking. Actually, what will happen in that case? Uh, like let's suppose I'm doing the three tasks. Okay, in case of multitasking. So what processor will be doing in that case? The processor will be switching between the different tasks, okay, at a very fast pace, so that like to our eye it will looks like multiple tasks are executing at the same time, but actually what is happening behind the scene is the processor is switching between the different tasks very fast, okay, like it can take even like less than a nanosecond, okay. So that effect like will not be visible to our eyes, okay, but actually what will be happening behind the scene, uh, at a one point of time only one task will be executed by the processor, but in that way like it will be switched between the different tasks, okay, so that like to our eyes it will looks like the multiple tasks are executing, but actually there is only one task that can be executed by the processor at a single time. All right, are you getting the point? So it depends
Then,
upon
sir,
what?
what is the
It depends upon the processing speed. Like if you'll be having the high processing speed, okay, then you'll be able to like running the multiple tasks smoothly. And you can see, you can observe sometime, like when you'll be running the multiple tasks, like uh, some of the tasks may not be executed properly, okay, or it may like stopped at some time, okay. Actually, what happened at that time, that switching time become more in that case, and in that case, like it can be visible to your eyes, and like you will be able to feel that, like it at this time only this task was running. Yeah. And same is the case with the multi-threading also. Like we are saying, like we can have the multiple part of the same program that can run concurrently, but that actually not true. Actually, what will happen? There, the processor or the running machine will like be switching between the different parts of the program. Okay, at a very fast pace, like it will looks like to us like these programs are running concurrently. Now here, like what will be the benefit of multi-threading in that case? Actually, here the overall objective of the multi-threading will be what? Like to make the optimum utilization of the processing power. Like for example, the first part of the like let's suppose the first part of the program has been executed for let's suppose 1 nanosecond, and after that it has become idle. Okay, so now your processor will not wait for that particular part to again become active. Okay, so in that case, like what the processor can do at that time, it can move to some other part of the program that will be executed. So in that way, your CPU will never sit idle. Okay, it will like always be performing a certain type of task there, because it is not going to wait for any particular task to complete in that case. Okay, so it will be switching between the different tasks at the same time, and like in that way, we will be making use of the optimum utilization of CPU processing power. So like this will be the overall objective of making use of the concept of multi-threading here. Yeah, let me know if anyone having any doubt in the theory.
sir? No doubt in theory, but I have a question regarding multiprocessing. So then,
Hmm.
what is multiprocessing?
Look, I told you the definition. Multiprocessing like will be like if we are executing more than one task at a time. Okay, but actually behind the scene, this is what will be happening. And same is the definition of multi-threading also. Like we'll be able to running the multiple parts of the program at the same time. But actually behind the scene, what is happening? Only one task is executing at the same time. But the CPU is switching between the different tasks at so fast rate, like it will looks like the multiple parts of the program are running concurrent. Okay, this is what will be happening. Are you getting it?
Yes, sir. Sir, then multitasking and multiprocessing are the same.
Yeah, multi-processing, multitasking is the same thing. Process and task are the same thing or not? We can say the process or we can also say the task.
Yes, all right, sir.
Okay, so here actually what we'll be doing is we'll be try to like make use the optimum utilization of the processing power that we'll be having, so that we'll be able to execute our program, okay, at a fast pace. Okay, so how can we create the thread in case of Java? So here we have a class name thread that we can make use of to create the thread, and we are also having an interface name Runnable. So there are the two ways to create the thread, by making use of the thread class or by making use of what? The Runnable interface. We'll see that later. Okay, so in Java you can do the multi-threading by, as I told you, if it will be class, then we can extend it. Okay, so we can say what, by extending the thread class, or if it will be an interface, or we can say what, or implementing the runnable interface. And some important method provided by them, okay, are as follows. Okay, so the first method that we are having get name, that will return you the name of the thread. Get priority, we can obtain the thread priority. The start is a thread by calling we can like start the thread. The run is a method that will be the entry point of the thread. Sleep, we can suspend a thread for a period of time. Join, wait for a thread to terminate. Is alive, determine if a thread is still running. Okay, these are some of the methods here. Okay, we'll see look, all of these methods we'll see later. Okay, in a much more detail, like when we'll be implementing the main thread. Look, Java is a multi-threaded programming language, and all the programs are executed here through the thread only. Like whatever the program we have written so far has also been executed by a thread. Okay, and the name of that thread will be the main thread. Okay, so the Java program we have done till now are controlled by a thread named what? Main. It starts running automatically when a Java program starts. Okay. Note that all the threads that you are going to create here in this chapter, it will be derived from this main thread itself. So this main thread will be created automatically, and we can create some additional thread that will actually will be derived from this main thread itself. Okay. So if you want to get a reference to the main thread, we can get that by using a method name of current thread. That will return you the currently executing thread. Okay, so if you want to see it, so what can we do is, here we have very simple program. Okay, so you can see here in the main method, what I am doing is thread.current thread. Okay, the thread class is having a method named current thread. What it will return you? It will return you the reference of the currently executing thread that I am receiving here in an object name T. And on that T, I can make you the method name what? Get name that we have seen, that will return you what? The name of the currently executing thread. And as we learn here, like the thread that is going to control the execution of all your program will be what? The main thread. So the answer here should be main. Let's see. Let's try to execute Java code. You can see here current thread name is what? Main. Okay. So whatever the program we have created so far, all are being controlled by this main thread that will be created automatically. Okay, now let's move towards creating the thread. There are the two ways, as I told you, by making use of the thread class or by making use of the runnable. First, we'll be seeing thread class. Okay, so a class need to inherit the thread class if it need to do the perform the task of what? Multi-thread. So a class can create a thread by extending the thread class, and there it has to override a method named run. Run is a method available in the third class. Okay, and here the thread behavior is implemented by the run method itself. Okay, and it forms the entire body of the thread. We have to follow the following steps. Like first of all, we can create a class that is going to inherit the thread class. This will be the first step. The second step will be what? We have to override the run method. There, like we can define the body of our thread. Okay. Then we'll create the object of the class and call the start method. Okay. So that will start the thread. And once the thread has been started, it will be ready to run. Okay. So start method automatically calls the run method, which contain what? The code of the thread. So here we do not require to run call the run annually. Okay, it will be called automatically when we'll start the thread. Okay, so let's see it. Okay, let's go. So here what we have done is, just see it carefully. So we have the class first. Okay, you can see that is inheriting the class thread. Okay, so this is the first step. The class need to inherit the thread class. The second step is what? It has to override the run method. And you can see here within the body we have override the run method, and what we define there? We define a loop that will run from 1 to 5. Okay, what it is going to print? First 1, first 2, up to first 5. So this will be the output of this run method. Then we have a second class that again going to inherit the thread class, override the run method, and again we have defined a loop that will print the second 1, second 2, up to second 5. In the same way, we have class third. Okay, that is also doing the same thing. Okay, the only thing is what? It will be printed in third 1, third 2, and so on. Okay, so now we have created this. Now we need to call the thread. Okay, so how can we do that? First of all, we need to create the object of the class. Okay, so here we have the first, second, third, three classes. So we can say like the thread T1 equals to new thread T2 equals to new thread, and so on. And there within the thread, what can we do is we can pass the object of that class. Like here, the T1 will be the thread that belong to which class? Of which I have passed the object here. So this is the first class. So you can say here the T1 is the thread that belongs to this first class. In the same way, T2 is the thread that belongs to the second class, and T3 is the thread belongs to third class. All right. So now how can I call, how can I run the thread? I need to start them by making use of the method name of start. So here I have started the T1, T2, and T3 by saying what? T1 dot start, T2 dot start, and T3 dot start. And what will happen at this point of time? It will automatically call the run method. Like when the T1 dot start will execute, it will automatically call the run method belong to the first class and will like start executing it. And here what will happen is how the execution will be performed here. Just listen it carefully. First of all, remember it. In case of multi-threading, like you can see here, you may be like thinking, first of all, the T1 dot start will start the class first. But it is not the case. In case of multi-threading, any of the thread can start their execution first. So like when you'll be executing for the first time, it may be the chance like the T1 has started the execution. And when you'll be running it for the second time or the third time, it may be the chance, let's suppose the execution has started from the T3 on. Okay. So depending upon the priority, any of the thread can start the execution. And here the priority will depend upon the various things. First of all, we can set the priority. Okay, that we'll see later. The second thing is what it will also depend upon like the what operating system you are using, what processor you are using, what type of JDK you are having. Okay, so there are the several things over which the priority will depend. Okay, so here we can't say like the it is the T1 that will start execution first. But let's just assume that like for example like let's suppose initially the T1 had start the execution. So it will start the execution of this run method, and you can see here we have the for loop. So it will start the execution. Like the first of all, you will be getting the first one, then first two, and up to first five. But here let's suppose after running it for the two time, like first one and first two. Okay, let's suppose it has stopped due to some reason. Okay, it has become idle. So in that case, what will happen when it will become idle? Though the CPU will not be wait for this to again come in a running state. So in that time, the CPU can jump to some other thread here and can start their execution. Okay. Meanwhile, like after running the first two, it can start the execution of what? The second or the third. Okay. Let's suppose it has started the execution of what? The second. And second one, second two, second three. And let's suppose after the second three, it jumped to the third one, third two, and so on. And like again, it let's suppose jump to the first one. So it will start the execution of the first one where it has been paused. Okay. So it will start from what? First three, first four, and so on. So this is how like it is going to be executed. And what we are getting, what benefit we are getting here, like we are minimizing the CPU idle time. The CPU will not sit idle whenever like there will be no task for the CPU to be performed. So it can be switched to some other part of your program, and that will be run. Okay, so in that way, it will make the execution of your program fast. Okay, so now let's try to see it. Let's see it. What will happen? Let's execute it. Just observe the output. As I told you, like there is no guarantee like which thread will start the execution. So you can see here, the T3 was the thread that will start the execution first, and it run for the 2 times. After that, it has jumped to the first one, okay, the first thread T1, and executed for the first 1 time. Then it jumped to the second one. Then it jumped to the first one, first two. So you can see here, wherever the execution has been paused, it has been resumed from there. Okay, you can observe it from the output of first as well as from the output of the third. You can see the third execution has been paused at 2. Okay, it has resumed with third 3 and so on. Okay, so in that way, your whole thread will be executing here. Okay, and when you'll be running it for the second time, you may get some other output. Okay, let me try to run it again, and you can see now this time the first is the thread that has started the execution. So every time whenever you'll be running, you can get the different output depending upon the different internal things that you are going to have in your PC. The overall objective here is what? Like to make the execution of your program fast. Anyone any
Sir,
doubt on
this
this? Yeah.
yes, sir. So this execution depends on what vectors?
I told you like it will be upon your what operating system you are using, okay, what hardware configuration you are having, what JDK you are having type of thing. There are the several internal things as well as like to some extent we can control the output. Okay, we have the priority here, we have the several other methods available, but we'll see that later. But only to some extent it can be controlled. But here in the first example, you can see we can't control anything. Yeah. Anyone any doubt?
Okay, sir. Clear.
Okay, all right. So this is the first way. I hope you are getting like how can you create the thread using what? Using the thread class. The second way is what? Like we can make use of the runnable interface. So the only thing that will be changed there in that case will be what? In place of in place of extends thread, we need to write what implements runnable. This is the only thing that will be changed. The runnable will also be having the run method that need to be override. Okay. So this is the only change required in your program. And now we have it, we can say like we are having the second way now to create the thread, that is what by implementing the runnable interface. Okay, so this is the second way here. Okay, and here the question arises like which one is more useful. So remember here, like there is nothing like one is having advantage over another. It's totally up to you, like which method you want to use to create the thread. Okay, so either you can make use of the enable interface or you can make use of the thread class. There is nothing like that one is having advantage. Okay, so now let me know if anyone have any
Sir,
doubt. Yeah. Yes.
so please run the code once. Multiple A.
Yeah. Yes. Any doubt?
नो सर, बस मैं ये देख रहा था कि ये भी सेम तरीके से रन होता है कि
As I told you, like everything will go as will exactly the same.
ओके सर.